Hello, this is lecture one. In this lecture, we will discuss the different types of data and how to summarize dependent upon the types of data. If you remember, in the introductory lecture, I spoke about an example of research where it was taking a sample of LAU students and asking them about their opinion regarding smoking on campus. And we started talking about variables, and we said that variables are actually every question that you ask, and the data point is the answer you get to that question. So what question did we ask? So what were the variables? So one type of variable was age. So in age can variable ID age one. And gender can also one of the questions that we wanted to ask. Um, Whether they smoke or not, again, another question. So I can call this variable as smoke. Another question that you may ask them was their GPA, for example. So GPA is another variable. Another question that you asked them was which campus they go to. So campus is another variable. You could have asked them about uh, how many siblings they have. So the number of siblings they have. So siblings could be also a variable. The number of siblings, not if they have or not, the number of siblings. You could ask them if they have transferred from another university. So transfer is another variable. Their major is another variable. One last, you could ask them, for example, for those that smoke, how many cigarettes per day? So cigarettes per day is another variable. Okay, I hope you noticed that I on purpose put them into two different groups, and the reason I did that is because these variables have different nature. So if you look at all these variables, age, GPA, the number of siblings, the number of cigarettes per day, hopefully you realize that all of these variables produce data that is considered numerical data. Yani produces number, numerical data. So we call these variables or this type of data numerical data. Whereas all these variables on this side produce just categories of data. So gender, male, female. Smoking, yes, no. Campus, Beirut, Biblos. Are you a transfer student? Yes, no. Your major, biology, chemistry, pharmacy. ما في numerical data. So this type of variable or data, I should say, is called categorical data. Okay? Categorical data. Okay. Having said that, I have to mention something about numerical data. So basically, numerical data, if you want to know if a variable if numerical ولا لا, think about asking the following question: can I calculate an average, and would the average make sense? If the answer is yes, then you're dealing with numerical data. If the answer is no, then probably you're dealing with categorical data. يعني مثلا ما فينا نقول لحدا campus, what is the average campus? It doesn't mean anything. We can ask what is the average age. That makes sense. So every time you have a variable that produces a data point that is a real number, I will explain why I'm saying a real number, then it's a numerical data. And every time you have a variable that produces just an information that categorizes things, that put things into categories, then it's a categorical data. So why I said the real numbers. Think about if I ask you, if I ask what's your telephone number. If hopefully, if I ask you about your telephone number, you're going to give me a number, okay? But telephone number is not numerical data. because the numbers that you're providing me are not the real numbers. Real numbers are numbers you can add, you can subtract, you can multiply. These are real numbers. Whereas for telephone number, if you try to calculate the average telephone number of a class, that is meaningless. If you try to calculate the average telephone number between you and your friends, again, it has no meaning whatsoever, though you're getting numbers. These are not the real numbers. These are just categories, or I should say symbols. Okay? So people have decided long time ago to use numbers as symbols, not for real number. Okay? So in that case, the numbers should not be considered a real number, and we should not treat them as real number, whereas we should treat them as categories. Another example where numbers are used as codes, symbols, rather than real number. I said your telephone number, your ID number, your credit card number, your actually, yani many examples. In fact, in research, when we collect information and we try to put that information in the computer so that to be able to analyze the data, remember I told you the data generated from research is utilized for estimation and inferential. So once you have collected your data from your survey, this data goes into the computer, and then we use softwares to summarize the information gathered. One technique that is widely used is entering the data into the computers as numbers. So we code the data. Yani, for example, gender. Gender, the answer to gender obviously is male, female. But we do not enter it as male, female. We enter it as, for example, 1, that will represent male, and 2, which will represent females. Why do we do that? Because it makes it much easier for data entry. It makes it much easier for data manipulation. It makes it much easier for storage space on the computer. Another example would be for example, all questions that are answered yes and no. Typically, yes gets a 1 and no gets a 0. So the 1 and the 0 here are not real number. There are symbols, codes, and therefore the variable is not numerical variable, it's a categorical variable. Okay? Whereas every time you ask a question and the answer are categories, مثل ما قلنا gender, for example, your do you have the flu, yes or no, your favorite color, um the car make that you drive, all of these are categorical variable. Okay, so for example, if you're studying patients that have cancer, the site of the cancer is categorical. So they may have the cancer in the liver, they may have it in the lungs, they may have it in the bone. Wholly categories, ما في numbers. You cannot calculate the average cancer site. But the size of the cancer measured in centimeter, that is numerical. So every time you measure size, you measure distance, you measure time, that is a numerical variable that produces real numbers that can be that could be utilized in a number fashion. Okay? So let's go back to the lecture and see if we can move through the slides. All right, so in this lecture, we're going to talk about the types of data and the scale of measurement. So this is just an introduction. The idea behind the introduction is to make a point that we need to understand the types of data. We need to figure out شو هن the types of data to be able to summarize the data, to present the data, to communicate data. You have to have an understanding of the types of data. Okay, so I told you we عندنا categorical data وعندنا numerical data. Okay, so some books call categorical data frequency data. They might call them qualitative data. Similarly, numerical data, some books they call them measurement data or quantitative data. In this course, we will stick to the simplest way. We will call it categorical data, and numerical data. Under categorical data, we have two scales, the nominal scale and the ordinal scale. And under the numerical data كمان عندنا two scales, the interval scale and the ratio scale, which I will explain in the coming slides. This slide is trying to explain the different types of scales. So, both on top are categorical data, and both on bottom are numerical data. But this one is a nominal scale, whereas this one is an ordinal scale. شو الفرق بين الnominal والordinal? So both of them are categorical data. Both of them are just putting things into categories, okay? The difference between nominal and ordinal is that nominal is like names, just categories. That's it. There's no more information. Whereas ordinal scale, in addition to putting things in categories, there is an inherent order of things. Think about year of university. So you start freshman, sophomore, senior, or junior, senior. Okay, every year is a category by itself. We cannot calculate an average. However, there is a very clear order. Clearly, you start with freshman and you end up with senior. Okay, and the order is clear for everybody. Think about when you talk about the army ranks. So ملازم أول نقيب I think رائد مقدم عميد. Okay, so these are categories, but there is a rank, there is an order, very clear order. Cancer. In cancer, we talk about stage 1 cancer, stage 2 cancer, stage 3 cancer, stage 4 cancer. Okay, the stages are numbered 1, 2, 3, 4, but you cannot calculate. These are just categories. However, it's clear that there is a certain order. In the pharmacy years, and pharmacy 1, P1, P2, P3, P4, again, these are very specific categories of pharmacy years, but the order also is very evident. Whereas if I ask about the major, if you talk about pharmacy, biology, nutrition, medicine, engineering, architecture, these are categories, but there's no order. Okay? Some people might start with engineering, some people might start with biology. There is no order. Another example, so if I ask you, how much do you like a certain professor? And the answer could go from very dislike, neutral, like, and very like. Here, obviously, you're provided with categories, but these categories they have an order, and obviously, we're talking about an ordinal scale. Okay, so nominal, ما في order. Ordinal, obviously there is an order. However, you may notice that the order or the difference from one level to the other level is not maintained. يعني بنرجع لقصة cancer staging. If you look at the stage between stage 1 and stage 2 cancer, the difference is not as important as when you go from stage 3 to stage 4. Stage 3 to stage 4, the difference is much, much, much bigger. Okay? So in ordinal data, though there is a rank, the difference between one rank and the rank that comes right after it is not maintained. So one time the difference is tiny, and another time is huge. The difference could be huge. So again, when I ask you about how much you like a professor, when you say very dislike to dislike, the difference is not that big. Both of you dislike the professor, but when you go from dislike to neutral, the change in opinion is very large. Okay, so the point I'm trying to make here is that with categorical data, when it's nominal, it's just categories, ما في ranking. With categorical data ordinal, there is a rank. However, as you move from one rank to the other rank, the difference is like you're climbing up stairs. The stairs that you're climbing up are not of equal distances. One stair could be much, much higher than the other stair. Okay, as I'm trying to show here in this graph. Once you move into numerical data, the thing that you will always have is that one scale, one step to the other step will be always of equal value. Always, always, always. Okay? So if you're going from value 30 to 31, that difference between 30 to 31, that's one value, is the same whether you go from 15 to 16 or 1 to 2 or 500 to 501. So as I'm trying to show in this picture, the steps are of always equal distances, and these distances we call them intervals, and therefore this first scale is called an interval scale because you have the intervals are constant. The intervals do not change. So one to the other, the interval doesn't change. However, the difference between interval and the other one, which we call ratio, is that interval scale does not have a real zero, whereas the ratio scale has a real zero. The example I always use is temperature. When you're dealing with temperature that is Celsius, 0 Celsius, so if you have a temperature of 0 Celsius, 0, okay, is not a real zero. What I mean by real zero is absence of value. When you measure a temperature of 0 Celsius, it is not the absence of temperature. In fact, 0 Celsius, there is a lot of temperature, but people have decided to call the temperature of freezing water 0. At 0 temperature, there is still a lot of temperature, because absence of temperature, this is where the molecule starts to stop to vibrate, and I think this is like minus 273 Celsius. Okay? So the 0 Celsius is not absence of temperature. What does it mean? It means as the temperature go from 0 to 1 degree, it's exactly as 1 to 2, exactly 1 to 2, 2 to 3, exactly. So the interval in temperature at Celsius is the same. It doesn't change, okay? So temperature difference between 1 and 2, here is it, between 30 and 31. We decided that that interval is the same regardless where you are on the scale. However, the difference comes where you start trying to compare ratios. So can we say that 20 degrees is double the temperature of 10 degrees? And the answer to that is no. 20 degrees is not double the temperature of 10 degrees. The reason is the 0 degrees is not absence of temperature. Whereas when you move into a ratio scale, where 0 is really absent. So for example, think about لنقول salary, okay? $0, you're not getting paid anything. The difference between $0 and $1 is exactly as the difference between $1 and $2, $2 and $3, $3 and $4, okay? So نفس الفكرة هون. There is an interval, the interval is maintained, but also there is a ratio. شو معناتها there is a ratio? Somebody getting paid $100, is that person getting paid the double of $50? The answer is yes. $20, is it the double of $10? The answer is yes. Why? Because $0 is absence of any dollars. I hope it's becoming clear what's the difference between the ratio and interval. So both of them, if you think about them as ladders, both of them, every step is exactly of equal height, equal magnitude. However, the ratio, you're starting at a real zero, yani at ground level, okay? If you climbed up, for example, 2 steps, and somebody climbed up 4 steps, excuse me, the person on the fourth is double the height of a person on the second, because the reference, the 0, is real absence of altitude. Amma an interval, okay, the interval, we are not starting at 0. It's like you already are at the 7th floor, and on the 7th floor somebody climbed 2 steps and somebody climbed 4 steps. فينا نقول يلي على 4 steps double the the height of this person on the second step? And the answer is no, لأنه اثنيناتهم already عندهم 7 steps below, 7 floors below them. So we cannot talk about ratio in interval scales, but we can talk about ratio in ratio scales. يعني فينا نقول double the value in ratio scales، ما فينا نقول in interval scales. Okay? Now, to summarize, nominal scale is the one that has the least amount of information. It just put things into categories. That's it. ما في any additional information. Ordinal scale هو مثل النومينال scale. However, you have one more piece of information, which is you have some sort of a rank. However, these steps are not of equal magnitude. Once you move into numerical data, you have one additional piece of information, which is now the steps are of equal magnitude. And therefore, we talk about interval scale. Okay? However, with the interval scale, we cannot talk about calculating ratios. To be able to calculate ratios, you have to move into the last scale, which this scale has the most amount of information. Okay? And here, not only the steps are of equal magnitude, but also the ratio can be calculated. And then we can talk about double and triple. Okay? So let's continue with our slides and see if going through the slides, we will revisit what we just covered with examples. All right. So nominal scales, مثل ما قلنا, simplest level of measurement. Data is just put into categories. When you talk about smoker, yes and no. When you talk about gender, male, female, it's a categorical. Nominal, لأنه في only categories, ما في ranking. However, since the data only has 2 possible options, we call it dichotomous or binary. Let's just take it further. لما بنحكي مثلا على more than 2 categories، مثلا race لنقول white, black, Hispanic, etc. في عنا categories, but there is no rank in these categories. Okay? Ordinal is also categorical. We also have categories, but now we have an inherent order, a rank that no one can deny. Okay? It's very clear that there is a rank. However, the difference between the 2 adjacent category is not the same throughout the scale. As I said, like climbing, you have a ladder, but every step is not of equal magnitude. And the example you have, it's what is called here. This is called the Likert scale when you ask people how much they agree or disagree. And it goes from strongly disagree, disagree, no opinion, agree, and strongly agree. First, I would like for you to notice that the numbers 1, 2, 3, 4, 5 are used, but these are not real numbers. They're just codes. The other thing I would like you to recognize that this is categorical data. We have categories, and it is ordinal, going from the lowest to the highest. And this order is very clear. So strongly disagree, disagree. The last thing I would like for you to notice is that the difference between 1 and 2, أو بالأحلى strongly disagree to disagree, is not equal to the difference between disagree and no opinion. Yani the difference between 1 and 2 is not the same between 2 and 3. And therefore, these numbers are not real numbers, they're just codes. Then we move into numerical data. That's where the difference or the letters are of equal magnitude. So once you know you're dealing with numerical data, you know that the difference between number 300 and 400 is exactly like the difference between 700 and 800. بعدنا ما عرفنا إذا interval ولا ratio، بس خلص that difference is the same. Okay, so the interval is maintained. Okay, I mentioned that, and the example given here is for temperature. 15 Celsius and 14 Celsius, that difference it's exactly the same between 20 Celsius and 21 Celsius. And then we talk about the fact that this is not a ratio because you cannot say that 20 Celsius is twice as hot as 10 Celsius. And the reason behind that is that the zero is not a real zero. Real zero معناتها the zero is absence of value. أما ratio, it has all the characteristics of the interval scale. In addition to that, it's a ratio scale, meaning here the zero is a real zero. It is the absence of value, and we can say that, for example, 20 kilogram is twice as heavy as 10 kilogram. One thing that I did not mention, and quickly I'm going to mention it here, في عندنا شيء اسمه continuous and discrete. Basically, continuous, obviously it has to be numerical. This is every time when moving from one value to another value goes through a continuum. يعني مثلا temperature لا تروح من 20 degrees to 21 degrees, it doesn't jump values. It goes through a continuum of values. And therefore it's considered a continuous. Whereas if I'm asking you how many children a family has, so it's either 0 or 1 or 2 or 3, it doesn't go through a continuum. يعني between 2 children and 3 children ما في شيء in between. It's just 2, 3. Okay? So that's discrete data. Mentioning some authors in some book, they talk about categorical data as discrete data. For us, what matters is that, okay, so categorical data is discrete, but however, numerical data can be discrete. For example, number of credits. So number of credits, you could be taking 17 credit or 18 credit or 19 credits. ما في continuum of value. Even if you're taking half a credit, so 17, 17.5, there's not a hypothetical continuum of values. Whereas if you think about somebody who gained a kilo, so their weight was 65 kilos and they gained 1 kilo, so now they're 66. This kilo not just appeared suddenly. It went through a continuum of grams and milligrams till it built up to 1 kilo. Okay? Time, for example, is continuous. مثل ما قلنا distance continuous, surfaces continuous. أما credits discrete. Number of siblings you have discrete. Number of courses you're taking discrete. Number of cars you have discrete. Number of cigarettes you smoke per day discrete. I hope the difference is clear. Okay, so continuing with the lecture. Okay, so here's the thing about ratio scales. Ratio scales, if you change a ratio scale just by multiplication or by division, so you just multiply or divide, what's going to happen is that the zero, remember this is a ratio, so that zero, which is a real zero, that zero will not change. It will remain a zero, and therefore whatever you're going to get is also going to be a ratio. So هنعطي example. إذا بنحكي distances in kilometers, okay? Kilometers is أول شيء numerical data obviously, and it's a ratio because 0 kilometer is absence of distance, and therefore it's a ratio. If I change kilometers into miles by multiplying by 1.6, 0 kilometers will give me 0 miles, and so on and so forth. Okay? I'm sorry, it's not by multiplying by 1.6, by dividing by 1.6. And therefore, 1.6 kilometer will give me 1 mile. So kilometer, which is a ratio, has been transformed through division into miles. Miles is also a ratio. You can apply the same principles for kilograms and pounds. Okay, so you change kilograms into pounds by multiplying by 2.2. The 0 kilogram multiplied by 2.2 will give you 0 pounds. Hence, you started with a ratio scale, which is the kilogram. You will end up with also a ratio scale, which is pounds. Think about money, changing dollars into Lebanese pounds. So how do you change $1 into Lebanese pound? You multiply, correct? Okay, so dollar can ratio, right? It's a numerical value, and it's a ratio. When you change it into Lebanese pound is also going to give you a ratio scale because the zero will give you a zero. Okay? Okay, one more thing. Now, if I take a ratio scale and through the change, I either do an addition or a subtraction, then the result is no longer a ratio scale for sure. هلا, whether it will be an interval scale or not, that's a different story. I have to check. However, it will definitely not be a ratio scale. Let's look at the example. In this example, we have a scale that is called the triple E scores, and we are told that it's a ratio scale. On that scale, we are given four values. So let's say student got 500, another student 550, 600, and 650. Okay? Now, you may notice that these four values are equidistant. I picked them to be equidistant, but I did not have to do that. It's just a matter of things to make things simple. But you should be able to answer the question even if the values are not equidistant. So what we are asked that the triple E has been turned to a different different scale, a different system score, and we are asked, did the change or does the new scale is it an interval, a ratio, or nothing at all? Okay. So what happened is that the 500 was turned into a 1.2, the 550 was turned into a 3.4, the 600 was turned into a 5.6, and the 650 was turned into a 7.8. Now to know if the new scale is interval, I'm sorry, to know if the new scale is ratio or not, what we need to do is we need to ask ourselves, did the change include just a simple multiplication or division? So, the first question that you ask yourself, what did I divide 500 by to get 1.2? To go from 500 to 1.2, I must have divided 500 by 416 point something. So divided 500 by 416 point something will give me 1.2. Is that true for all other values? Well, take 550 and divide it by 416. You will get 1.32 and not 3.4. Similarly, if you divide 600 by 416, you will not get 5.6. And if you divide 650 by 416, you will not get 7.8. The point I'm trying to make is that changing the triple E score into the new system score is not a simple multiplication or division. It's actually using something else. And therefore, the new system score is not a ratio. Remember, we said if you start with a ratio, to get a ratio, you should multiply or divide by a single value. يعني مثل مثلا changing قلنا kilograms into pounds, you have to multiply by 2.2. Okay, 2.2 is a constant; it doesn't change. Whereas here, we're not multiplying or dividing by constant; something else is happening, and therefore this is not a ratio. So question number one, we answered it. Question number two, is it an interval? Now remember, a ratio by its nature is also an interval. Yani a ratio is an interval plus. Remember, an interval means that the intervals are kept. Yani the steps are kept. What I mean by that, think about the difference between $50 and $100. Okay, or $100 and $200. If we use the old rate of 1500, so the difference between 100 and $200, okay, if you change that into Lebanese pound, the difference between $100 and $200, okay, and look at the difference between $200 and $300. In dollars, these differences are the same. turn it into Lebanese pound, you will find out that the $100 change into 150,000, the old rate. The $200 changes into 300,000, and the $300 changes into $450, 100 pounds, 400, 450 Lebanese pounds. And you will see that also the difference between 150 pounds to 350 pounds is the same as 350 pounds to 450 pounds. Yani the interval is kept. So, since these points are equidistant, and now you understand why I took them equidistant. The difference between 500 and 550, 50. And 150 to 600 is also 50. And 600 and 650 is also 50. So the jumps here are 50, 50, 50. If I move into the new scale, is the jump also equidistant? And going from 1.2 to 3.4, that's a difference of 2.4, right? Okay. From 3.4 to 5.6, is it also 2.4? And the answer is yes. What about 5.6 plus 7.8? Is also the distance 2.4? And the answer is yes. Therefore, this new scale is an interval scale because the interval was kept. Okay, how do I know the interval is kept? Because I started the ratio scale by its nature is an interval. So I was able to look at the distances and ask myself, هل يا ترى equidistant spaces will result into equidistant spaces? طب what if I did not have the 600? Think إذا I did not have the 600. Now I'm going to take out this 600 out, and I'm going to take out this 5.6 as well. Okay? If you're given that scenario, how should you proceed? Well, you ask yourself, what's the difference between 500 to 550? The answer is 50. Now, 550 to 650, the answer is 100. So you say, okay, so here I have 50 steps, and here I have 100 steps, meaning the distance from here to here, when I'm talking about distance, مش ratios, is double the distance from here to here. Is that true on the second scale? Let's ask ourselves. So the distance from 3.4 to 7.8 is 4.4 steps, whereas the distance from 1.2 to 3.4 is 1.2. So you notice that the distance here is the double the distance here, and therefore you can conclude that this is an interval scale. Okay, هلا the key in everything we're doing here is that this 500 was turned into a 1.2. Yani that student here is the same student here. Okay, let's look at another example. In this example, we're given the IQ score. This is a scale, and we're told the IQ score is a ratio scale. We're giving that. That's something that we are given. And again, we're provided with 4 patients or 4 people, and their IQs are 100, 105, 110, and 115. Again, in this example, they are equidistant. Now, what is the question? The question is, there's a new scoring for intelligence, which is not the IQ. It's based on the IQ, but you're asked to fill the leftover values in such a way that this new scale comes out to be an interval scale. Okay, لما بنقول interval scale, it means just interval, not a ratio. But and so part A, or do it again so that you get a ratio scale. Okay. Okay. Now, the interval scale is pretty easy because again, I gave you equidistant values. All you have to do is fill these so that they are equidistant. Okay. The minute you fill them in such a manner that they are equidistant, that would be an interval. So 5, 10, 15, 20, that's an interval. 5, 6, 7, 8, that's an interval. 5 and 105, 205, and 305, that would be an interval as well. Okay? Type, how would I fill it out so that it's a ratio? Here I have to use my knowledge of the fact that when you move from ratio to get a ratio, you have to use either multiplication or division. So the question becomes, what did I do to 100 to get a 5? Obviously, I had to divide by 20. Okay, so 100 divided by 20, it will give you 5. So 505, I have to divide it by 20 to get the answer. So 105, if you divide it by 20, you will get 5.25, if I'm not mistaken. Yes. So 105, you divide it by 20, you get 5.25. You take the 510, you divide it by 20, you get 5.5. You take the 515, you divide it by 20, you get 5.75. So filling the values as 5.25, 5.5, and 5.75 will yield that this new scale is actually a ratio. Why? Because changing from the old to the new, we used either a multiplication or a division. Again, I did not have to give you equidistant, okay? So again, I could have, for example, removed the 105 from here and ask you to fill the rest. If I do that, you should be able to fill these two. Why? How? Well, you ask yourself, how many steps between 100 and 110? The answer is 10 steps. And how many steps from 110 to 115? The answer is 15 steps. So automatically you realize that the distance from this to that is double the distance from here to here. So all you have to do is find a value here. You calculate the distance between these two, and then you add just a half of it to get here. So let's say you decided that this is going to be let's say 6. If you decide that this is going to be 6, the distance between 5 and 6 is 1 point. So you add to 6 half that distance, which is half, and therefore this has to be 6.5 to get an interval. Okay? Now, if you're asked to fill it out so that's not an interval and not a ratio, now you have to make sure that whatever the relationship between the distances observed here, that distance is not respected. Okay, so if you fill that 5, here 6, 7, then this is no longer an interval. Okay, because remember the distance from 100 to 110 is double the distance from 110 to 115. When you change these values into the new scale, the 100 became 5, the 110 became 6, the distance is 1 unit, but the 115 became 7, again the distance is 1 unit, and therefore you distorted the distances. The distances no longer, the interval no longer are constant, and therefore you lose, and it's no longer an interval, it becomes an ordinal scale. One more thing I would like to mention about data interval. As I mentioned previously, the one that has the least amount of information is nominal, the categorical nominal, and you start adding up information, you reach ordinal, more information, you reach interval, more information, you reach ratio scale. That means if you are provided with a ratio scale, you can change it into something of lower quality. You can, because you're going from high information to low information. But if you're giving low quality, you cannot move into the high quality. Let me explain that. Let's suppose you're given your grades on an exam, okay, and you got an 87. Now your grade on exam is a ratio scale. 87 is a ratio. If you want to change this into an ordinal scale being letters A minus, B plus, B minus, you can, okay, because you are provided with the most rich data. So changing your 87 into a letter grade, you can do that. And if you're provided with a letter grade, let's say B plus, and you want to change it in something that is lower, مثلا pass fail, you can. However, going the other way around, you can't. So if you're told that you passed the exam, okay, all you're told is you passed your exam. Can you guess your letter grade? No, you can. It could be a C plus, it could be a B minus, it could be an A. You don't know what it is. Furthermore, if you're told that you actually scored an A on the course, can you get your exact final grade? No. All you know, it's an A, above 90. But it could be 91, it could be 95, it could be 99. You don't know. Okay? So similarly, if you were told your blood pressure, can you change your blood pressure? Let's say that your blood pressure is 125, and now can you change it into an ordinal? Is either hypo or normal or hypertension? You can, okay, because you're provided with the ratio, which is the one that has the most amount. You know that 120, a blood pressure of 125 is normal pressure. You can. However, if you're told that you have a hypertension, so you're provided your blood pressure on an um, uh, ordinal scale, can you guess what is your exact blood pressure? No, you can't, because you're not provided with the most amount of information. Changing the scale from higher to lower is something that we do a lot, and I just provided you with two examples. Grades are changed into letters, and things like blood pressure are changed into high, mid, medium, and low blood pressure. Okay, so that concludes the first part of this lecture. The second part is how do we summarize these data? So how do we summarize categorical data? How do we summarize numerical data? That is going to be in the next part of this lecture.